Hey guys, I'm Jerry, co-founder CEO of LlamaIndex, and today super excited to be here. Today we'll talk about evaluating and optimizing your RAG application. Where's the clicker? Okay. Right. Okay. Show of hands, how many of you guys know what RAG, Retrieval Augmented Generation, is? Okay, I asked this question. Great, that's like over 60, 70%. That's awesome. Okay, so many of you know what RAG is. And so maybe just to take a step back, we'll try to frame this with some context, and this will hopefully explain some of the motivations for LlamaIndex itself as a project. And many of you already might know this, so I apologize if it's redundant. So LLMs are a phenomenal piece of technology for knowledge generation and reasoning, right? Like they're pre-trained on large amounts of data. You ask ChatGPT, GPT-4, anything about that's like pre-2021, it generally knows about it. You can, ask it questions about like books, ask it to write code for you, even ask it to like debug stuff. So in general, they're used for a lot of different types of use cases: question answering, summarization, structured data extraction, all the way to kind of agent planning. So, ever since the beginning of this project, ever since this project was started around like last November or so, we asked ourselves, like, how do we actually best augment these language models with our own private sources of data? That really is pretty much the mission statement of the company. And so anything from raw files like PDFs, PowerPoints, Excel sheets, APIs like Notion, Slack, vector DBs, any sort of data DBs like data warehouses. How do we just like bring all this data into the language model itself? Because the language model inherently isn't going to know about it. So of course, like many of you have heard about fine-tuning, and especially in the past few months, I'd say like fine-tuning has had a resurgence, and within LlamaIndex, there's actually support for both like embedding and LLM fine-tuning. But the idea of fine-tuning is really just like about baking in knowledge as well as reasoning capabilities into the weights. And it can be a way you can bake in knowledge, actually. Like, I mean, you just ask like ChatGPT, right? Like, without any sort of RAG, you can basically ask ChatGPT to give you information about like the state of the world pre-2021. Of course, the main paradigm that LlamaIndex focuses on is this idea of like retrieval augmentation, where generally you keep the model fixed, and then once the model is fixed, you basically just figure out a way to kind of like put stuff into the prompt so that it generates the correct output. I had this like tweet thread a few days ago, but basically RAG is just fancier prompt engineering, right? Like if you're familiar with prompt engineering, this is just a fancier way of like creating a data pipeline to feed into the prompt input itself. So a quick note on LlamaIndex for those of you who aren't familiar with the framework. LlamaIndex is a framework for building LLM applications over your data. And so it's a tailored set of abstractions for both data ingestion as well as data querying so that you can basically build that pipeline that I just described to how to like wire data from your data source into the language model to build any sort of application, right? So from the very simple stuff, just basic Q&A chatbots, all the way to stuff with like memory, and then all the way to stuff that automates like your workflows with agents and beyond. So the three main components of LlamaIndex are basically the following. One is a set of like data connections. We have a variety of data connectors on Llama Hub, from like unstructured and structured data to load in PDFs, databases, API contents. Once you load in this data, you want a way to be able to like transform and parse this data, basically define this new type of ETL stack to really transform this data into some sort of storage system. These days, a popular storage choice, of course, is this idea of a vector database. Of course, you can use other storage systems too. You can use like a key value store, a structured data store as well. Once this data is in a storage system, and by the way, this like whole like ETL process really is like, if you're familiar with it, right? Like you take in a PDF, split it into a bunch of chunks, and throw it into a vector DB. I just described, I'll go into this in just a bit, but I just described like a very simple stack of how this works. Once the data is in a vector DB, you then have different ways of like interacting with the data. And so as a very basic process, you can basically do something where you do retrieval from your vector DB, and then you do synthesis, right? Once you do that, you can basically create an initial kind of RAG application where you query the vector DB with like top K embedding search, and then stuff all the context into the prompt. So you could use the LLM once throughout that whole process, or you could do something more fancy. You could use the LLM for reasoning and actually kind of retrieval itself, so do more calls to the LLM. You can use it for agent-like loops where you can break down a complex question via chain of thought, query planning, and actually execute arbitrarily complex tasks. So again, to start with, like one of the advantages of LlamaIndex, if you're just starting out, there's a bit of like formatting mishap. I should really fix this. But basically, like you can basically get this out in like 3 lines of code. You can build chat over any sort of documents. So if you don't really know what you're doing, it's totally fine. You can basically just like 1 line, load in some documents, 2, index it, 3, ask it some questions, and then you can do that, right? And so for beginner users, it does offer some high-level abstractions that you can just go in and try like building stuff on your own. Of course, the whole point of this talk is like, once you set up some sort of like basic like RAG stack, 1, it helps to understand how it actually works under the hood. 2, it helps to understand why it's failing, because once you build this, inevitably there's going to be failure modes. And then 3, figuring out how to properly evaluate, benchmark, and then optimize this type of application. And as an AI engineer, this new term that's been coined recently, anyone who's building with LLMs basically should internalize these sorts of practices, whether you're from like a data science ML background or a software engineering background, to actually try to improve the performance of your application. So let's go through what the current RAG stack looks like, right? Okay, this basically looks like the following 2 components. 1 is you have data ingestion, and the second piece is you have data querying. So let's talk about the first step. And again, you can wrap this whole thing in like 5 lines of code in LlamaIndex. And again, if you haven't done it already, I would encourage you to do so, at least just to understand where it doesn't work. And then you can follow this talk. So then the first step here is data ingestion. So you have your data. Let's just say it's like a PDF for simplicity. Let's say it's like the GPT-4 or Llama 2 PDF paper, like on archive. You load in this data using a PDF parser. And then you split it up into a bunch of chunks. You can use any sort of text splitter. You split it by sentences, split it by tokens, use any of the tools within our framework or other frameworks. And then each chunk basically is just a piece of like raw text, right? And then once you take this text, you can then generate an embedding for each piece of text. And the way this works is usually make like a call to OpenAI's embedding API, or you could use like a sentence transformers model, or basically any embedding model that you want, right? Just some sort of thing that takes in unstructured text and gives you back a vector of numbers. And then you take these pieces of text along with their embeddings and throw it into a vector database. That's data ingestion. That's basically this new form of ETL that's emerging. The next step is once you actually have this set up, you query the vector database, right? Most popular vector DBs these days all of them expose some sort of semantic query capabilities. Some of them expose additional like filtering upon beyond that, and I can talk about that in a bit. But the key idea is like you take this query, embed it, and then you fetch the top K most similar documents to this query. And then now you have like the set of chunks, right? They're just like raw pieces of text. It's honestly like kind of primitive if you think about it. Like it's just like a bunch of random pieces. And then you take these pieces of text and you just like shove it into the prompt. Right? And if it doesn't fit, you just figure out a way to make it fit. And you can do some sort of like response synthesis strategies to make this happen. And LlamaIndex has like abstractions to basically help you guys with this so that like you don't have to worry about how to deal with like, overflowing context windows, those types of things. We can help you manage that. So, okay, we talked about how RAG works. We talked about what LlamaIndex is. And now let's talk about what are some of the challenges with this existing stack. So there's basically like a variety of failure modes that you'll run into. And anyone who's actually like kind of built some of these chatbots, right, built RAG, you guys might have encountered some of these things. Like there's both like quality related issues, and most commonly this is stuff around like hallucinations, like accuracy is not giving you the right response, it doesn't know how to give you the answer. There's also like non-quality related things, like it could be cost, it's costing too much money, it's too slow. Like your data's out of date, and so you don't actually have a way to like properly kind of update your vector store with the right type of information. I think for the purposes of this talk, I'll probably talk a little bit more about response quality and less on the other stuff, but all these things are super important topics that are worth kind of like, honestly, like separate sessions on their own. In terms of like quality-related failures for RAG, one of the most common issues is just bad retrieval. And a lot of times bad retrieval is not really like an LLM problem, it's just like an information retrieval problem. And of course, you can use LLMs to help with this process. There's a few aspects of bad retrieval. One is low precision. When you return a bunch of documents that are relevant to the query, maybe you like only some of them are actually relevant, and a bunch of it is actually just junk, right? And so the issue with current LLMs these days, if you just like throw in a ton of context with like maybe some relevant items, and especially if it's like in the middle, you might run into hallucination issues, and then you might run into like lost in the middle issues. For those of you who don't know what that is, it basically means that the LLM a lot of times attends to context at the beginning and end of something, and like cares less about stuff in the middle, right? And so if you end up retrieving stuff where the relevant stuff's in the middle, it's not going to be able to use it effectively. Another idea is low recall, and basically this idea is you kind of return some relevant context maybe, but not all the relevant context is actually returned. And so this just leads to bad results, because in the end, like if you don't return the relevant context and ChatGPT or your LLM doesn't actually know about the context, it's not going to be able to synthesize the right answer. And so how do you deal with that, right? And so one of the issues here is basically, you're just not able to return the relevant pieces of context for the LLM to actually do its job properly. And of course, there's like this other issue of outdated information. On the kind of response generation side, right, some of this is related to bad retrieval, some of this isn't necessarily. Once you return a bunch of stuff, then you actually have to kind of generate a response with the LLM to give you back the final answer. There's some issues around like hallucination. A lot of times the LLM can just make up stuff that's actually not in the retrieved context. So even if the context contains the relevant information, the LLM doesn't quite understand it, or it makes up a bunch of stuff. There's like irrelevance. It could just make up an answer that doesn't actually answer the question, but is technically faithful to the context. And of course, it could always output something that's offensive or harmful. So, okay, we talked about some of these issues. What can we do to try to improve it, right? And like in the end, when you're building these types of LLM-based systems, it's not really just the LLM, like input and output prompts. It's like an entire like network of different modules that you kind of have to play around with and have intuition for what to experiment with to try to actually diagnose and also improve the performance of the system. And so there's data. Can we store additional information beyond just like the raw text chunks? Right, like again, the current like naive RAG stack is just like you have a bunch of text and you just like split it up, right? And it's just like raw text blobs. Embeddings, can we do better than just using a pre-trained embedding model? Can we optimize the embedding representation in some way? Retrieval, can we have like more interesting retrieval mechanisms beyond just like top K and kind of like understanding more concretely where does top K actually not do well? And then synthesis, like can we actually, in the current RAG stack, the LLM's basically only used to generate a response. A lot of heavy lifting is done by retrieval. Can we use the LLM during the retrieval process or actually use it in a more complex way than just using it once at the end? Before all this, though, we kind of need a way to actually measure the performance of these things. Okay, so the next section of this is before you actually try any of these techniques, you should at least define some basic benchmarks, right? It could be eyeballing, just looking at it on a single data point and seeing if it works. You probably shouldn't do that in the long term. And then you should maybe try defining an actual benchmark. And then you should define a benchmark for both like the retrieval and also the evaluation portions, or the response generation portions. So how do we evaluate a RAG system? There's kind of like two ways you can do this. You can evaluate in isolation, take the pieces of it and break it up into different components and evaluate each one independently. You can also evaluate it end to end. It's kind of an open question which one you should do. I kind of waver between them actually. I think these days I'm actually leaning towards you should probably evaluate end to end first just to get a gut check of what's going on, and then go in and try to actually fix the parts that are broken. But there's basically two main components, right? There's evaluating retrieval, synthesis as like individual components, or given like a query and the final generated response, you could just evaluate the whole thing end to end. So the way you evaluate retrieval, and again, this isn't really, by itself, isn't really like an LLM problem. So if you're familiar with like IR, Rexis, like this is not new. You can basically just like take in like a user query, get back a retrieved set of like document IDs, and then figure out a way to kind of like measure the performance of the retrieved IDs against your expected document IDs. So the way this works is first you want to collect a data set. You could do this manually via like humans. You want queries and ground truth context, like documents, or you could do this synthetically. I have a next section on how do you actually do this synthetically. Once you actually have this data set, you can run your retrieval algorithm over this data set to benchmark how well this retrieval algorithm performs. And then you can measure the performance of this via some ranking metrics, right? Like given the retrieved IDs and some expected IDs, it's basically a ranking problem. You can measure stuff like success rate, MRR, hit rate, like, or like precision. Like there's a bunch of these metrics that you can use. Here's one idea where you can use the LLM to actually kind of like generate the evaluation data set for retrieval. One thing you can do is, take in this document, and similarly to how you want to break it up into a bunch of chunks for a RAG system, break it up into a bunch of chunks. From each chunk or from each like pair of chunks, ask GPT-4 to actually generate a bunch of questions from these chunks. If you've tried this, you kind of need to do some prompt engineering to have it actually work well, so that doesn't like focus on the wrong pieces of context. But assuming it works well, right, this is kind of like a thing that's an exercise left to the reader, then you can basically get a bunch of like question chunk pairs. That's your evaluation pairs. And then like going back, like this basically is, and then now you basically have a data set. You have questions, you have the ground truth context it's mapped to, and then you can just run evals against your retrievers to compare against these contexts. The other piece here is like evaluation end to end. So how do you evaluate like the final generated response given your input? So one, again, you want to collect a data set. Here it's basically just like input queries or tasks, and then the output, instead of being the context, it's like the ground truth answer, right? It's like the final thing that you want to have. Of course, anyone who's like tried to deal with like evaluating the quality of responses knows that it's quite hard to do so. Like traditional metrics like Blue, Rouge scores don't really work super well. The new popular trend is to try to use like GPT-4 or any sort of like good LLM as a judge to evaluate whether or not the generated response is good, whether with respect to the context or with respect to a reference like the ground truth answer. So the ground truth answer in this case is technically optional. You don't really need it if you have like other ways of just evaluating whether or not it's good. If you have the generated answer, you can compare it against like the retrieved context, for instance, to measure like faithfulness. But having the ground truth obviously gives you another kind of dimension that you can evaluate against. Similarly here, you can do synthetic data set generation for end-to-end evals. Right? You can take a document, parse and chunk it up. Now you ask GPT-4, like before, to generate questions from each chunk. And then you take each question and the chunk and you pass it through GPT-4 again, and you get back a ground truth response, right? This is like a synthetic but ground truth response that, again, doesn't run through the full RAG pipeline, because the point here is to generate like ground truth, but gives you like a reference answer that you could benchmark like a full RAG system against. So a quick note on like LLM-based eval modules, similar to what I was talking before. They're starting to become like very popular and relevant, and the reason is like pretty much 90% of like both companies as well as like developers I talk to care about evals, and the reason is people generally are still figuring out the best practices for how to do so. They're running into these failure modes. They're trying to understand, how do I actually evaluate the quality of this thing, do it in a cheap, reliable way, and then use that to actually improve the performance. So a lot of people are turning to like GPT-4 as a grader to actually try to evaluate the quality of these responses. In a label-free manner, like if you didn't have the ground truth answer, you can evaluate the quality of the response against the context. You can evaluate whether or not the response matches the query. You can also just insert a bunch of guidelines. Like depending on your use case, you can specifically say like, hey, this thing must not output anything that's like racist or harmful. This thing must output something that's structured like a JSON. You can encode that in a prompt. With labels, you can actually just have GPT-4 or like, just any sort of comparator. Like it could be embeddings to compare the generated response against the reference answer. Okay, so now we have a benchmark. You've defined it, whether you kind of manually did it or you used GPT-4 to generate something. Now you can start thinking about techniques for better performing RAG, right? So there's just like some general kind of like tips and tricks, which I've mentioned at a few times in the past, but like a lot of these are just general categories of things that you should try. And then really for your use case, it's just a bag of like different things that you should try, and then see which ones against your eval benchmark actually work well. Right? And the other kind of like unscripted note is, don't like overfit on the test data set, right? Like have a separate validation and test data set, because you don't want to like overfit and then in production realize that your thing actually isn't doing well. So raw text chunks that's what's being used in the current naive, the naive RAG stack, and it can bias your embedding representations with filler content. And especially if you're using a pre-trained embedding model, you're just dumping like the raw text chunk in. And so this is just a diagram from one of our webinars from Max from Sid.ai. And there's just a lot of stuff within a raw text chunk that might bias the embedding representation. So then when you run retrieval, you might not actually fetch the most relevant content. So an idea that you can basically try is this idea of small to big retrieval, where you can basically embed text at a sentence level and then expand that window during LLM synthesis. This intuition is basically that retrieving on more granular, smaller pieces of context generally works better for at least fetching the relevant sentences from the document. But then once you fetch the relevant sentences, you want the LLM to actually have enough context to synthesize a coherent response. And so this kind of balances between having too much context for retrieval and too little context for LLMs by just doing both, right? You kind of take in the sentence, embed the sentence, look at it, and then once you have a reference to the rest of the text, try to actually expand that window. The next piece here is that you can try to, oh wait, no, this is the same thing, never mind. So basically the next results I was just gonna show is with sentence window retrieval with a top k equals 2, with slightly smaller text chunks, the generated answer over this climate change report actually gives you back a coherent response. The issue is that when we set k equals 2 on naive retrieval, especially for this specific question, with naive retrieval, you're actually not able to get back any relevant context, and then you have to widen the top k. And then once you widen the top k, now you have the relevant context is actually in the top 5 now, but it's somewhere in the middle, right? And then you have 4 other chunks that are completely irrelevant to your question. And so by doing kind of something more naive, you have to widen the top k, which leads to a bunch of filler context, which actually leads to bad performance for your LLM. It can't actually synthesize the answer, even though the context is found somewhere in the prompt. The other idea here is you can try embedding references to text chunks instead of the chunks directly. I've actually updated the eval numbers here. I tried running it a few more times, and it actually works pretty well. This is something that you should definitely try. And the idea here is basically have a bunch of chunks. Let's say there are 1,024 tokens, just by default. That's the current stack. Then you embed smaller chunks that link to that bigger chunk. So maybe you embed 128 tokens. So there's 8 per 1024. And then you embed those and that's a reference to the parent chunk of 1,024. When you do retrieval on the smaller chunks. And then similar to the previous idea, you basically kind of use the bigger chunk for synthesis. So use the smaller chunk for retrieval, use a bigger chunk for synthesis. And so just this general idea of embedding a reference to some outer chunk that's used during synthesis can be a powerful idea to both improve retrieval and also generation performance. Maybe the intuition here is probably just similar to the previous one, where a lot of times you want to retrieve on more granular pieces of context, but again, you want to kind of expand that window to fill the LLM with more relevant context for the actual question. And then the other thing I would say here is just being able to do some sort of hierarchical retrieval. This is something that is if you have 1,000 documents, I found that for naive RAG, the current RAG stack, if you have 1,000 PDFs, you break everything into a bunch of chunks and just throw everything into a vector DB. It tends to not work super well. Sometimes it helps to embed things at a document level, and then you go down and actually embed the chunks. So actually modeling your data in some sort of hierarchy can lead to more advanced retrieval algorithms and then better results down the line. Great. I mean, there's a QR code, but I mean, I can also send this out. It's in our docs. You can basically Google production RAG LlamaIndex. So if you miss this, don't worry about it too much. But it's all in our docs basically. And this again, disclaimer: I'm not saying that any of these are guaranteed to do better than what you already have. They might come with trade-offs. They're just things that we've tried that empirically have improved the performance for specific use cases. And before all this, you should define a benchmark. Right? Cool. A little bit of a note on fine-tuning. I know I just said that we're kind of like separate from fine-tuning, but like in reality, they're all like a little bit complementary. Like if you imagine what the current software stack is for RAG, it's like you embed stuff, put it into a database, and then you fetch that stuff and then put it into an LLM. Both the embedding model and the LLM can be fine-tuned and optimized. So you can, like within RAG, fine-tune either the embeddings model or the LLM. I think these days, like there's a lot of hype around like LLM fine-tuning. Fine-tuning the embedding model, it's just training the embedding model basically. It's more of just like a classic ML process, but it's definitely something that can improve your retrieval performance. So in terms of fine-tuning embeddings, I've already kind of said how you would generate like a retrieval data set. And the way you generate a training data set for fine-tuning embeddings is basically the exact same thing. I think Joe from Vespa actually brought this idea up in the first place during one of our webinars. But you just like generate a synthetic query data set from a bunch of documents, take these queries, add the kind of ground truth context as like training pairs, and then you can basically do some sort of contrastive loss between the query, the ground truth pair, and then any other context pair. And then this will basically fine-tune the embedding representations. What does this actually give you? This gives you better retrieval performance, right? Like over your data domain. So if you find that like a pre-trained sentence transformers model doesn't work well, or you're actually, OpenAI tends to do better for what it's worth in general, but sometimes you just can't use OpenAI, or you actually want to fine-tune OpenAI embeddings too. Like how do you actually do that? And then, like how do you actually optimize the embedding representations? So there's different ways that you can actually try fine-tuning your embeddings model. If you have access to the model itself, like sentence transformers is just PyTorch, right? You can run it locally on your machine. You can actually just fine-tune the model. If you don't have access to the model itself, like for OpenAI embeddings, like it's just a black box API, and they give you back the embedding. So then you can actually try fine-tuning. You can actually fine-tune like a transformation. You could fine-tune like a cross-encoder transformation or just an independent transformation on top of the embeddings itself. So basically adapt the embedding. Like the input isn't text, the input is an embedding to your new space. So, I mean, this is just a basic diagram of how this could work in terms of the adapter. You have the embedding model. One catch here is that for us within LlamaIndex is like, when you actually want to fine-tune your embeddings, fine-tuning your embeddings, like all your document embeddings, is a little tricky, because once you fine-tune the embedding model, you have to re-index all your embeddings, right, across all your documents. This can be tricky if the set of documents is very large. So if instead, you had like a ton of documents and you don't want to re-index everything, you could just keep that part frozen, like freeze your document embeddings, and then just fine-tune your query embeddings, right? Once you fine-tune the query embeddings, then during query time, you only have to like transform the query and not your document. Here's another QR code. It's also it's in the docs too, but also try sending the slides out. And I think that's it. Cool. Thank you.